Hello and welcome back to this channel. Dear students, this topic is quick revision for power device protection and circuits. So let us start the session. In this video, we are talking about the revision of different protection circuits that are used for power devices and circuits. So first is overcurrent protection. From the exam point of view, you may expect the question like this. What is overcurrent protection circuits? What are its different types? Explain any one in detail. So, overcurrent protection, as the name indicates, whenever due to any reason the current flowing through a particular power device like MOSFET, SCR, IGBT, and so on is increased beyond a certain limit, it may cause damage to that particular device. So, certain protection is to be used, that is called overcurrent protection. The common reasons why the current increases is due to there may be certain faults in the circuit, or there may be occurrence of surge current. Surge current is the any current which is getting exceeded beyond a specified limit for short amount of time period, or there may be short circuit or overload condition, because of which the current flowing through that power devices may get increased than the specified limit. So that is the overcurrent. There is one particular term which is called sub-cycle surge current. So it is defined as the magnitude and rate of rise of the surge current for a small duration is called sub-cycle surge current. To limit this current or to provide this protection, different techniques are used. One, you can protect the circuit using fuses, then you can use a crowbar circuit, or you can use MCCB circuit, that is modulated case circuit breakers. Now we will talk about how to make use of fuse so that the protection can be obtained. There are two types of fuses. One is glass fuses, second is semiconductor fuses. In case of glass fuses, the blowing takes place very slowly. So in case of power devices, semiconductor fuses are preferred where fast blowing takes place. This is one corresponding circuit diagram in which we have shown four SCRs, SCR 1, 2, 3 and 4. In series with each SCR, I have drawn one fuse. So this fuse is used to give the protection against increase in current, because whenever the current increases, the temperature of that particular device increases if you are not using any protection circuitry, and because of which the device may get damaged. So we are making use of fuses in series with each SCR. This is the single phase AC supply. In series with single phase AC supply, again we are making use of fuses. This is the corresponding graph how the fuse works. See, if you are not using a fuse, then the normal increasing current is like this. It will start from 0, it will reach up to point B. B is the point which indicates that if you are not using any fuse, any protection circuitry, then the current increases up to point B. But we are using fuse to protect the SCR. So the current rises up to point A. At point A, this is called T melting point. That is the time period at which melting of fuse takes place. So whenever melting takes place, the arcing between the terminals takes place. This is the fine wire, melting of wire takes place, because of which arcing takes place. Due to this arcing, or the corresponding time period of this arcing is denoted by T arc. So due to this arcing, this circuit gets open circuited. I mean, this particular thing gets open circuited and current reduces within short amount of time period. This current gets reduced to 0. So this is the way how the fuse operate, and this is the overcurrent protection circuit for power devices. Next is over voltage protection, which is used for power devices. From the exam point of view, we may expect the question like this. What are the different over voltage protections, and explain any one in detail. First of all, what is the meaning of over voltage? If due to any reasons the voltage spikes are generated in the circuit, and these voltage spikes appears across the power devices like SCR, it may damage the device. So we need, in such cases, we need the voltage protection circuitry. Now the question arises, from where we are getting these power spikes or voltage spikes. It may be due to the fluctuations in the supply voltage, or there may be the changes in the commutation circuit, or the voltage spikes may be generated due to the commutation circuits used for SCR and so on. So different techniques to provide such over voltage protections are, you can use LC low pass filter to block the higher frequency voltage spikes. Second, you can use the snubber circuitry. So basically snubber circuitry offers low impedance path for current produced by voltage transients. Voltage transients means voltage spikes. And third is we can use metal oxide varistors, that is variable resistors. This is the circuit diagram of snubber circuit. Snubber circuit is one of the techniques which is used to avoid or which is used to provide the over voltage protection for say SCR. As shown in this diagram, these three extra components are used: diode D, resistor R and capacitor. If these components are not present, if you close the switch, then there may be a step change or step voltage will be applied across SCR, due to which the voltage spikes may get generated and it may damage this SCR. To avoid this, we are using this extra circuitry. We are considering of SCR. Initially, let us say SCR is in forward blocking mode. That means let us say initially SCR is in off condition. In that case, whenever SCR is off, the charging of capacitor takes place like this through this diode, and this charging of capacitor takes place. This diode gets forward bias. It has very low impedance in forward bias. So as if the capacitor is directly connected across this SCR. So, since the gradual change or gradual increase in the value of capacitor takes place, we can say easily that there will be gradual change in the voltage drop across SCR, because as if this capacitor is directly connected across SCR because of very low forward impedance of this diode. Whenever this capacitor gets fully charged, at that time, after getting fully charged, this point's voltage gets increased, because of which diode gets reverse bias. That means this path will get open circuited. Now whenever this second mode, whenever this SCR is turned on, at that time the capacitor get a discharge path through this resistor and then it will get discharged through this SCR. Now there is an important role as far as this resistance R is concerned. Whenever the capacitor gets discharge part, there can be sudden current or sudden current spikes generated, which may damage this SCR. To protect this current spikes, this resistor R is used. So R, you can say it is used to limit the current. So in this case, as far as the designing of snubber circuit, this particular circuit is called a snubber circuit. As far as designing of snubber circuit is used, is considered, two major equations you need to remember. One is dV by dt, that is rate of change of voltage, is 0.632 times Vs upon Rc, and second value of resistance is Vs upon ITD, where ITD is discharge current of the capacitor. Next part is heat sinks. From the exam point of view, you may expect the question like this: what is the use of heat sink? Draw its equivalent diagram, and what are the design considerations of heat sink? So basically, the heat is developed in case of power devices. So there should be certain mechanism in order to dissipate that heat. That is done by using the heat sink. So heat sinks are designed by using certain materials, for example, aluminum material, on which power devices are mounted, so that the heat can be transferred from power devices to that heat sink, to that particular material, and then it is radiated to the ambient. This is the major use of a heat sink. This is the equivalent circuit which represents the power device mounted on the heat sink. So different points are shown. Tj, that is temperature at a junction. This is the point which indicates the junction. This is the case point. This is the Ts, that is the temperature at sink, and this is the Ta, that is ambient or air temperature. Theta represents the thermal resistance. So theta Jc is the thermal resistance between junction and case. Then between case and sink, it is theta Cs. Then between sink and ambient, it is theta Sa, and between case and ambient, it is theta Sa. We can easily write the equation that the total thermal equivalent resistance is addition of these. That means total thermal equivalent resistance will be the thermal resistance from Tj to Ta, that is theta Ja. So which is theta Jc plus theta Cs plus theta Sa. And using electrical equivalent analogy, we can say that the power dissipation is given by Tj minus Ta upon theta Ja, where we discussed theta indicates the thermal resistance. Now, as far as the design considerations are concerned, this value of theta Cs depends on the material that you are using for the manufacturing of heatsink. Usually, aluminium material is preferred because aluminium is having higher conductivity. Then value of theta Sa again depends on the type of material as well as the area of the heatsink. The area of the heatsink should be large enough so that the heat can be passed away easily and in a faster sense. Then the heatsinks are mounted vertically, and as I mentioned, the area should be large enough. So these are a few design considerations as far as these heat sinks are concerned. Certain cooling techniques are also used. If you are using cooling techniques, then it will help us to reduce the effective area of the heat sink. Now let us discuss how to solve numericals related to heat sink designing. The given problem is for a thyristor, maximum junction temperature is 180 degree. So this is the given junction temperature, that is 180 degree. The thermal resistances are theta Jc is 0.16, theta Cs 0.08. These values I have already written. For the heatsink temperature of 70 degree, given temperature initially is 70 degree, calculate total average power loss in the thyristor sink combination. If heatsink temperature is reduced to 50 degree, that means next time the temperature is reduced to 50 degree, calculate new average power loss. Now these numericals are pretty simple. They are just based on only one formula. So this is the equivalent diagram. This point represents junction, this point represents case, this represents sink. So temperature at the junction is Tj max, that is maximum junction temperature. This is T sink, temperature at the sink. Thermal resistance between junction and case is theta Jc. Between case and sink is theta Cs. And total power loss or power dissipation or maximum power dissipation between junction and sink is denoted by Pd max. Now, we have to refer this formula. Pd max is Tj maximum minus T sink upon theta Jc plus theta Cs. Simply put the values. Tj max is 170 degree, T sink is 70 degree. This is 180 degree minus 170 degree upon 0.16 plus 0.08. If you solve this answer is 458.33. In the second part, this is the calculation related to 70 degree. In the second part, it is asked if the temperature is reduced to 50 degree. So simply make the change. Instead of 70 degree, it will be now 50 degree. So new answer will be 541.66 watt. This is the way to solve the numericals related to designing of heatsink. Next part is ZCS or ZVS, that is zero crossing switching and zero current switching and zero voltage switching. From the exam point of view, you may expect the question like this: what is resonant converter, and what is the need of resonance conversion, and what are its advantages? So the definition is, it is a switching converter which contains LC network. Inductor and capacitor LC network is also called a tuned circuit or tuning circuit. So it is also known as tank circuit, and it is tuned to resonate at a particular frequency. Now, what is the need? We have studied different switching power devices which are used to switch on and off the load current at very high speed. It may produce losses in the system, that are the switching losses. So to eliminate all these switching losses, we need to make use of some different techniques, that is perform the switching whenever current or voltage crosses the zero line. That's what we are doing in case of resonant converter. Now, because of this switching, if you are not using resonant conversion, then since the switching takes place at very high speed, that means it takes place at very high di by dt. D by dt of I indicates rate of change of current. So it produces losses, switching losses, as well as it creates electromagnetic interference. To avoid this, we want to make use of this resonant converter. Now, what are its advantages? Designing is simple. Switching losses are reduced, efficiency is improved, then it reduces electromagnetic interference, that is EMI. cooling requirements are reduced, it eliminates high frequency harmonics, and it reduces the power consumption. Next, an important part is electromagnetic interference, that is EMI. From the exam point of view, you may expect the question like this: what is EMI? What are its effects, and how the EMI is transmitted? What are the techniques which are used to reduce down the EMI, and so on. So basically, in case of power devices, the switching action takes place at very high frequencies, due to which the switching transients are generated. So these switching transients are generated in case of power devices, which is called radio frequency interference, abbreviated as RFI. This radio frequency interference causes or creates the electric field, rather electromagnetic field. So EM field, that is electromagnetic field, which is generated, which is created by RF, that RFI, that is radio frequency interference, and this field varies or changes with respect to frequency, which is called EMI, that is electromagnetic interference. Now, transmission of EMI takes place due to two reasons. First is radiated EMI, second is conducted EMI. As the name indicates, in case of radiated EMI, the transmission of electromagnetic interference is taking place due to induction effect. That means there will not be direct conduction, but due to radiation, due to induction effect, the transmission of EM energy takes place. This EM energy transmitted is in the form of electric field, and it occurs due to induction. Second is the conducted EMI. As the name indicates, the EMI gets transmitted due to the conduction effect. So conductive path gets developed directly from source to the destination, source to the receiver. It may be due to the transmission through the cables which are used for connecting different devices, then PCB tracks, then parasitic capacitance, and so on. So this is the list of some sources of radiated EMI, which contains mobile devices, electric motors, SMPS, then transmission lines, power transmission line, TL means transmission line, radar systems, and so on. Whereas some sources of conducted EMI are DC to DC converters, electric motors, then SMPS, then microcontroller, power supplies, and so on. So this is about the definition and how the transmission of EMI takes place. Next, an important part, how to minimize EMI. That means what are the techniques, by making use of those techniques we can reduce down the electromagnetic interference. So there are certain methods. First is resonant switching. Again, there are two types of switching. One is hard switching and another is soft switching. If you're choosing hard switching in order to reduce down the EMI, then in case of hard switching, you are supposed to make use of resonant filters. But if you're using hard switching, then EMI will not be totally eliminated as far as inverters are concerned. So in order to minimize the EMI in inverters also, you should make use of soft switching. Soft switching means the techniques which we already studied, like zero current switching, then zero voltage switching. So whenever the current or voltage crosses zero line, then switching takes place. This is called soft switching. So by making use of soft switching, we can reduce down the effect of EMI. Second most important or commonly used technique is make use of shielding. There are certain materials, if you use those materials as a shielding, then the effect of EMI can be minimized, because the shielding causes bypass path, produces bypass path to the electromagnetic interference. So this shielding material may be in the form of metal wires or metal foams and so on. So if there is a spurious noise or electromagnetic interference, then that can be bypassed by making use of this shielding. This shielding is as shown in this figure. Second or another third method is make use of filtering. This is LC filter, which is also called radio frequency filter, RF filter. So high frequency HF, that is high frequency voltage and currents, can be suppressed by making use of this RF filter. So these are certain techniques which are used to minimize EMI. Now last part of this session is isolation transformers. We'll discuss what is isolation transformer, what is its need, and what are the applications. As the name indicates, isolation transformers are used to isolate the power devices from AC supplies. So it is used to transfer electric power from AC power supplies to the power devices while isolating the devices. This provides galvanic type of isolation. That means there is no physical contact, but like the normal transformer, primary and secondary windings are separate, so it provides galvanic isolation. Then what is its need? Basically, whenever you need isolation of a secondary from the earth, or if you want to step up or step down operations, or to reduce down this noise signal, then applications areas, it is used as instrument transformers in order to make the measurements, because in case of instrument transformers the voltage levels are high, so for the measuring purpose step down isolation transformers are used, voltage levels are reduced and then measurements are carried out. Then it can be used in computer measuring devices, then power electronic devices. Then it can be used as a pulse transformer to generate the pulses, I mean rectangular form of pulses at different intervals, and it can be used in computer network designing. So dear students, that's it for today's session. So thank you. Thanks a lot for watching this video.